In this video, we're going to create a reusable music crossfader. So what I mean is if I play a music track, you'll hear it fade in. We could also fade between two tracks. Right, you can hear it fade between those, and we can also stop the music and fade it over time. And the cool thing about the way that we're going to build this tool is it's very, very simple to use. So you can see we just call it in one line. We're going to use a lazy instantiation singleton, meaning that it doesn't even exist in the scene. But when we press play, it will create it the first time we access it. So I'm gonna press space. So it'll create it, set it all up. By the end, we'll have a reusable system that only uses 2 scripts, and we can pull this into new projects. So you should be able to reuse it, which is very cool. We'll have our music manager, which is our singleton, handles all of this. And then our music manager will create 2 little music players that will handle each of their own fading so that when I press play, you can kind of see it in action. We have our music player, audio source, music player, audio source, and then they will fade over time. So if I press Q, right, we're going to fade the volume on the audio source. So this is going to be the approach that we'll take. I know that there are other approaches that might give you higher fidelity, for example, fading mixers and things. But for this approach, I wanted something that was easy and reusable. Build it once and you can pull it into new projects and not have to worry about it. You can always go into something more complicated if you like. All right, let's start making our music manager and music player. So what I'm going to do is first create a new scene if you haven't already. So file, new scene, and I'm going to select empty. We don't really need anything since we're just testing audio. So once I do this, I'm also going to make a new folder. We'll call this Music Player. So I'm in my new scene, and let's just save this somewhere in case our computer crashes. We want to be able to come back to it. We'll call this Music Player Tests. Okay, right now I have it over here. We'll just pull that out. We'll separate out our music player folder later. And now I want to create my 2 scripts that I need to make everything work. So my first one, if you right click, create, C#, call this Music Manager. And then our second script is going to be the music player. Our music manager is going to create 2 music players on an object, and those are going to be the 2 music players that manage an audio source and fade them up and down. So our music manager is going to be our singleton that will spawn our music players, and then our music players will have a lot of the functionality on them. So first thing we need to do is set up our music manager. Let's open that up. So the first thing to do is we need to make a singleton. Now I want this to be pretty easy to use. I just want to call one line of code from some other script. And if it doesn't already exist, I want to create it and set it up. So we would call that lazy instantiation, meaning that we don't have to drag and drop this in the scene. We don't have to remember to do that. If it's not already in the scene, then this script will allow us to create it. So this is our internal singleton instance that we'll use for tracking, and then we'll use this public one so that anything else can see it and get it. Now I'm going to use a property here, meaning that if anything tries to get or access this, then we can do some checks. So for example, I'll mark this lazy instantiation right here. If our instance is null, because we have not filled it in yet, then let's see if there's one inside the scene. Okay, so we're searching our scene to see if we find anything with this music manager component. If it doesn't find that, it's still null. We haven't found it. Then let's just create one. So we'll make a new singleton game object. Give it a name just to, make it organized. When it gets spawned in the scene, we'll rename it. Let's add this music manager component. Let's add this component to the object that we just created. And then we're going to assign our singleton instance to the component that we just added. So this music manager that we just created and added it to our new game object will be our singleton. And lastly, we will don't destroy on load so that we can use this between scenes. You might have some loading screen or something that you want the music to continue through, so this makes sense to me. And lastly, once we do all this, it either doesn't exist, we find it in the scene, or we make one, or it already exists. Either way, we're going to return our instance. So if anything publicly gets access to our instance, then we return the private instance. This just means that publicly things can't reassign it. We're doing this all in here, and so it's pretty protected. Next, add our awake function. In awake, we're going to enforce our singleton pattern, meaning that if there is already an instance, right, if it's not null, and that instance is not equal to this, this one is a duplicate. It shouldn't exist. So we'll delete it. And we'll just go ahead and return so that we don't accidentally run some code after, just depending on when this gets called. So we know at this point that this is our singleton. This is the one. Any excess ones will get destroyed because it'll already exist from this. This is where we would do any setup, which you haven't really done yet, but we'll say setup music players. All right, so we mentioned that our music manager is going to be in control of 2 music players, which will fade music in between, because if we're fading out one track, we want the second track to fade up, meaning that we need 2 music players at any point in time. So let's go ahead and spawn those. Let's create a variable to hold on to these. So we'll say MusicPlayer1. We'll have a MusicPlayer 2. And then the other thing that I'm going to need is I need to track the active music player so that we know which one we want to fade up. So we're just going to switch between MusicPlayer 1 and 2, and we'll set this in a second. But this is my third variable, but it's not MusicPlayer 3. It is going to be active music player. And for now, it's null. We'll reassign this whenever we switch between the two. So we'll just swap between it and we'll just point it to which one we want. So we have these. Let's actually spawn these so that we can see it inside of Unity to make sure that our system is getting set up properly. We can do this right here. I'm going to make a function for it though. Let's call this private void setup music players. And we'll make sure to call this right here. Okay, so what we want to do is we want to take each of these empty containers right here, this empty music player container, and we are going to assign it to a component that we are going to create and add to the same object that our music manager is on. So we can, it's trying to autocomplete for me, but MusicPlayer1 is equal to, let's take this object and add a new component of type MusicPlayer, which remember is our second script over here that we have not used yet. We're going to do the same thing with MusicPlayer2. You can see that sometimes Visual Studio will try to smartly guess what we're trying to do, which in this case did work. And then this one's kind of weird, so I'm going to leave a comment. Choose a starting active music player, meaning that we want to specify which is the music player that we want to load our first track into. And we'll just say active music player is equal to MusicPlayer1. All right, so MusicPlayer1 will be our starting one. So if we want to know what the active music player is, we'll just access it right there. We have our setup right here. And then another thing that I want to add, because I know I'm going to need it later, I've already said it out loud a few times, switch active music players. So let's say private void switch active music player. So if we're on MusicPlayer1, we want to switch it to MusicPlayer2, or if we're on 2, we want to switch it to 1. There are a lot of ways you could organize the logic for this, and some that are much shorter than what I'm about to do, but I think this is the most descriptive way to do it for a tutorial. So I just want to be very clear on what I'm doing. Very specifically, I am saying if active music player is MusicPlayer1, then let's just do a one line here. It is now 2. Make sure that you are doing these equals properly. Double equals for comparison, 1 equals for assigning. So we're assigning active music player to player 2. Then we're just going to do the reverse. If active music player is 2, then it's 1. So we're just switching between the two. Since we only ever have 2, it's fine. It's not really a big deal. Probably make that an else if, because it's really going to be one or the other. Make sure that you have this if and then else if, and then we'll run one of the two. All right, so the last thing I want to do is test everything we have so far. So if I Control S to save, for now, I'm going to put this in the scene, but long term, we won't need to. We'll just call it from a script and it'll create itself. Just to make sure that everything is spawning properly though, I'm going to make a new object. We'll call this MusicPlayer Tester and Control S to save. Let's add our Music Manager script. I'm also going to zero these out. Okay, so when I hit play, our Music Manager is going to, because it's not spawning itself, it already exists. We'll go down here and we're going to set up our music players. So if everything is working properly, we should see a music player component get added, then another music player component get added, and that'll all happen right after we press the play button. So let's test it out. Press play. There we go. Okay, so these 2 music players that spawned, we're going to have those manage their own audio source, and then we'll have those fade and fade out. But our music manager needs to create and set up and manipulate our 2 smaller music players that will do our fading. Now let's open up our music player and start adding our setup over here. So let's get rid of that. And in Awake, what I want to do is each individual music player should spawn its own audio source that it can use to do its fading on that audio source. So I want 2 different music players, each responsible for their own audio source. So we're spawning 2, which means that this class only needs its own private audio source. We'll just call it what it is, audio source. And then inside of Awake, we'll say audio source. Let's actually spawn this as well. So whatever object we're attached to, let's add component audio source. It should just autocomplete there. Audio source dot looping. We do want to turn on looping, right? Because most music should loop. If you don't want that, you could turn that off if you like. But by default, I think it's probably best to keep it on. We'll also want to do play on awake is false. We shouldn't have anything preloaded into it, but just in case, let's set that up. Control S to save, and I come back and I hit play. Our music manager created 2 music players. Each music player that was created its own audio source. So now this music player will control this audio source, and this music player will control this audio source. The next step is to start thinking about the type of functions that we might want in our music player. Let's say one thing I know I need is I want a music player to be able to play. In this case, autocomplete is fighting me, so let's just type it in. We'll take in an audio clip, call it music track, and we know that we want a fade time. That's the whole point of this thing. Another thing we might want is a stop. Ooh, another autocomplete fail there. So remove that. For our parameters for stop, you might ask the question, well, what do we want to know in order to stop? And in this case, we want the fade time. So we want to fade it out down to 0. We'll add this functionality in a little bit. And lastly, as part of this, we want a fade, let's call this fade volume, where this function will be responsible for fading up or down the volume. So we'll kind of pass this through each one, because stopping is still fading the volume down to 0. Play is fading it from 0 up to 1. So we can reuse this function, which will be nice later on. So we want a float target volume, whether it's 1 or 0 or something in between, and we want a fade time. So we have our methods kind of set up and prepared over here. Let's do the same thing over in MusicManager. Before I do my methods, another thing I'm realizing that I might need is a global volume. So we have these 2 music players underneath here. We want to set the volume in one place and have that propagate to our, multiple music players. So we want to do this in the Music Manager. We don't want to track 2 different volumes and 2 different music players. So in our Music Manager, let's add a private volume. We'll default it to 1. It's pretty common. Oh, we need that to be a float. And then let's do a public property to expose that. We'll say public float, capital V volume. And let's just say if you're trying to get it, just return it. But I think I do want to clamp this, because in most cases you want it to be between 0 and 1. So let's just ensure that if something tries to get the volume, it never goes below 0 or above 1. So we'll clamp it. We'll say private set whatever value we're taking in. This is the new value. Let's clamp it. We'll clamp the value variable to 0, minimum, 1, max. And then we'll assign that. We'll set our private variable to the right here. Okay, just a little bit of extra precaution there, but might be helpful. I'm going to minimize that because it's not important that I really see how that works. I'm also going to minimize our singleton. We'll just label this singleton pattern. All right, just trying to give ourselves some space. Let's track our active music track. So this will be an audio clip. In other words, if we're trying to play Dungeon Song 01, we want to track that that's Dungeon Song 01. That way, if we try to play the same Dungeon Song 01 again, we can just ignore it, right? We don't want to replay the same song. That would be a little bit weird. So let's track what the current, I'll call this clip, but I'll just say track, active music track, and we'll use that for testing in a little bit. All right, let's add our methods. Finally, I keep saying this, don't get distracted. So public void play. Again, this is going to be very similar to the MusicPlayer methods that we did, because our Music Manager is what people will access. And this Music Manager will just tell the active player to play. So we're kind of pushing it down. This will be our entry point. So it's going to look very similar to the other play and stop and whatever else. A music track and a fade time. So that's our play. We also have a stop. It'll be float, fade time. We have everything set up, and now we just need to put in the functionality into our methods on both of our classes. Okay, now the tedious part. Let's start filling these out. It's just going to be a lot of logic. I won't explain everything, but we'll try to get through it. So first, let's guard ourselves. I would call this a guard clause. If new music track is empty, then let's just return. We don't want to do anything if that's the case. If our music track is the same as our active one, then we'll also want to return. Don't do anything. So don't replay the same song over and over again. If you don't want this feature, you could always remove this part if you want to be able to retrigger the same song. Let's try to figure out what we're doing here. We're stopping the current player. So that's going to be if our active music track is not null. If we currently have something playing, then we want to stop the currently active one. So later on, we'll like fade it out and stuff. We'll put in a fade time. Oh, not the track here. We want the active music player. This is our active music player, like one of these two on our other class. So I want to stop that one if it's currently playing something. We then want to switch our active music player because that one stopped and faded out. And so we want to make the other one that is inactive, the newly active one. So just for ourselves, switch to new player while previous fades. And we already made a function for this down here, switch active music player. So we're just switching to the other one, switch active music. Yeah, just double check spelling. I'm trying to type pretty fast here. So now the other one is the active one. Let's also mark what our currently active music track is. So this is our player, but the track is going to be the music track that was sent in. This is our Dungeon Song 01 or whatever. If that's now our active track, then it won't try to replay the same song over and over again. So we'll say active music track is now the music track that we passed in, this one right here. So this is now the active one. And lastly, now that we've done our fading, we've switched our active one, we just want to play the new song with fade it up. And to do that, we're going to active music player. Remember, this is one of our, or whichever of our music players is now the newly active one, dot play. And send it the music track, just pass along the fade time as well. And so this is going to go into the music player that is active and then run this. Or if we were stopping the inactive one, it would go in and stop right here. So for our stop, if we don't have a track, there's no need to stop. So let's say don't stop if we don't have a track yet, right? We're trying to stop something that's empty. So we'll say if active music track is null, then return. Let's just do that on one line. It's pretty simple. Otherwise, clear out active track and stop. The active music track that we're keeping track of, I guess, should now be empty. And let's tell our active music player to stop. Pass through the fade time. So this would be if we were currently playing a song and we just said stop, then it will clear it out and then tell it to stop and we'll fade out. All right, so this is, again, calling the music player stop. So we're calling play and stop a couple times over in the Music Manager, but it's only getting called on the active one or the inactive one, I guess. And then these will run individually. But for now, I think that is the Music Manager and everything we need. Long term, we could always add additional functionality, but for now, I think this is all I need. So now let's go into our music player and let's actually put in all the logic for playing and fading. So let's start with play. We want to start at 0 volume and fade up. Want to fade this track in slowly from nothing. So let's enforce that. We'll say AudioSource.volume started at 0. We're going to set the clip to music track, and then we're going to start playing. Now it may be at 0 volume, right? But we're going to start playing at 0 volume and then fade it up while it's playing. Now you could do some additional checks in here if you want. The reason I'm not is because I'm already doing the checks up here in Music Manager, right? But technically our music player is public, so theoretically you could call this if you hook in different ways. If you want those checks, you can, but that's the reason I'm leaving it off. Thought it was unnecessary for this demo. After we start playing, we want to slowly fade up the volume. And really, this is kind of an unnecessary comment because we have a method for that. So we'll say fade volume. We'll pass in our volume, get access to the volume over here, whichever volume is set on the Music Manager. So we're going to access that through our Singleton, our instance.volume. So whatever the current volume on the Music Manager is, use that for the target volume. And then the fade time, we'll just fade it up using the fade time that we passed through a couple different functions. We're just passing it along until we get to wherever it is needed. That is our whole play method. We just need to do our fade volume, which is a little bit complicated because over time, we probably want to do some kind of coroutine. Usually when I'm working with coroutines, I like to make a variable to hold onto it. That way, if I'm running a process over time and I want to restart it or reset it, I can look back at the variable and just reset the one that I'm tracking. If you don't do this, then you're starting coroutines that are just fire and forget and they'll override each other and it gets very confusing. So I'm going to make a variable for this. We'll call this coroutine I don't know, lerp volume routine makes sense to me. Another thing is when we're using coroutines, we need to add something to the top using system.collections. This variable will hold on to the routine that we start, so that way we can clear it or restart if we need to. So inside of our fade volume, let's make sure that the target volume is between 0 and 1. We're kind of already doing this in the get, right? We know that we're sending this in. So I'll say target volume equal to the same variable, set it to minimum 0, maximum 1. Just a little extra check there. We'll also check to make sure that if fade time is less than 0, then fade time is 0, right? If we give it a negative fade time, let's just pull that up to 0. Clamp 01, autocomplete. I don't know why I did that. mathf.clamp. So we've done our checking and our guarding, but now if we currently have a coroutine running, I want to clear it so that I can set a new one. If our lerp routine is not null, meaning that we have one running, then let's stop it. So stop coroutine volume routine. And now we can start a new one. So lerp routine is equal to, let's start a new one. Start coroutine. And now it's looking for an IEnumerator to begin. And so we haven't made this yet, but let's type it out. Lerp volume routine, and then we'll give it a target volume and a fade time. So this doesn't exist yet, and it's trying to autocomplete. Let's replace this. And I like to name this pretty much the same as my routine that I'm tracking up here, but capitalize it instead of the variable down there. Okay, so we're getting the red squiggle here because it doesn't exist. So let's create it. This is a private IEnumerator, lerp volume routine. It should match this name over here. So really you could copy and paste it like that. We do want to send a target volume and a fade time. So this autocomplete worked out. It's great. And it's still giving me the red squiggle because at some point I need to return something so that it can process it over time. What I would normally do is yield return null to get rid of the error while we're figuring it out, but we'll change this a little bit later. So we'll put that down there. First, I like to declare my variables, my local ones that I need. So we have a new volume. This will change constantly. We'll calculate a new one, and then we'll move it to the new one. Then we'll calculate a new one, then we'll move it to a new one. And each cycle will incrementally move it over time. So our starting volume is going to be whatever the audio source current volume is. We could force this to 0, but we don't know because we could be fading a volume between a 0.5 and a 0.75, for example. So we'll just say whatever the starting volume is. Then we're going to do a for loop. Now this is the big tricky part. I'm doing a for loop here to increment over time. I'm going to relabel these variables to make it a little bit more clear what I'm doing though. So we'll say float elapsed time is equal to, let's start at 0, and then we'll count up. So our elapsed time is starting at 0. Then as long as, this is our condition, elapsed time is less than or equal to our fade time. Our fade time is 2 seconds. If we've elapsed from 0 to 2 seconds, then we want to stop. So only do this as long as it's been 2 seconds, essentially. So after we do this, we increment so that we can do it again. Then this is going to be elapsed time. Let's set the new elapsed time is plus equal to time.delta time, which is our time since our last cycle. So first we need to calculate our new volume, right? This is our local variable. Let's calculate a new one. Our new volume is equal to mathf.lerp. This just returns something between 2 different points. So we'll do our start volume, our target volume. So this is our start point and our end point, and this is the position in between that we want. We'll say elapsed time divided by fade time. So this is our current time divided by our total amount of time. It should give us a fraction. So if we're halfway through, our elapsed time is 1 second and our fade time is 2 seconds, this should return 0.5, which will give us the value between our start and our end. And then we want to set our audio source volume to be equal to whatever this new volume that we calculated is. So we're calculating a new volume incrementally between our start and our end, and then we are setting that to be the new volume. And then we want to wait until the next frame, yield return null. There we go. Now we can remove the one at the bottom. No errors. Wait until the next frame, then calculate it again. Move the elapsed time just a little bit more, get the new volume, wait, move it a little bit more closer to the fade time, get the new volume and move it. So it should be this slowly moving slider from start to end over time. Lastly, just in case our final pass is just a weird decimal off, let's just set it to the target volume if we've made it this far. If we've made it this far, set the target exactly. Audio source dot volume is equal to target volume. Okay, so this should be our fading. Again, we're just going to go through all this and then we'll test it at the end and then fix any issues we have. The last thing we need is our stop function. So if something calls stop, we want to do that too. Just to protect myself, I'm going to make a separate coroutine for stopping, just in case we mix up our fades and our stops. I just want something to restart if needed. So we'll say coroutine underscore stop routine, default it to null, that's fine. And we'll come down to stop. So when we stop, let's reset it if it's already going, right? So if we currently have a stop routine, let's kill it and start a new one. So stop routine is not equal null. So if there's already one going, then stop. And which one do we want to stop? The stop routine. Kind of a mouthful there to say. And then start a new one and assign it to stop routine. It's equal to, let's start our new one, start coroutine. We'll call this stop routine fade time. All right. What we want to do is we want to call our fade out and wait for the duration of the fade out and then actually stop, like tell the audio source to AudioSource.stop, like really tell it to stop. So to do this, let's make another coroutine down here. We'll make it underneath at the bottom since these are private. Enumerator. Whoop, there we go. Stop routine. You probably want to copy paste this just in case. So Control C, Control V, stop routine. We're looking for just a fade time. Okay, so fade time. If we're currently doing a volume fade, let's also kill that too. It's a little bit confusing with two coroutines talking to each other, but I want to lock it down as much as we can. Cancel current running volume fade, stop prematurely. So if we currently have a volume fade going, let's stop that. So if it's not null, then it's currently going. We'll say stop coroutine, lerp. All right. And then let's start a new one. We're inside of one coroutine, reusing another one. Coroutines are wild. You can chain them together if you want. Let's start a new one because our stop fade is still a volume fade. It's just a different type. Start coroutine. What do we want? Our coroutine is called lerp volume routine. And then we are passing in 0 because we want to fade it down to 0. This is our target. And over what amount of time? The fade time, which we did not pass in right here. So let's do that. Take this, set up our parameters. So that's float fade time. So really we're passing this in. We're making sure that we had it passed in up here and semicolon, can't forget about that. Let's wait for blend to finish. So yield return, instead of returning null, we're not waiting till the next frame. We don't have to because our lerp volume routine is doing that automatically. We just want to wait until our lerp volume routine is finished, which is pretty cool. We can do it this way. Yield return lerp volume routine. Just wait until our other routine is finished. And then once we have waited, our total fade time and our volume fade is finished. Let's officially AudioSource.stop. I think this is good. I know there's a lot of typing. I moved pretty quick, but just double check for any errors. All right, now it's time to test our system, make sure that it works. So first thing I'm going to do is, it sounds weird, I'm going to delete my music player from the scene. Instead, I'm going to right click and make a new, let's call this level tester. And let's create a new script that we can use just for testing. Inside of, wherever you're making this, I'm going to make another script. Let's call this MusicPlayer tester. This script is throwaway. I mean, it's just to prove that our thing works. We're not going to hold on to it once we finish our system. But for now, let's drag this MusicPlayer tester script onto our game object. So I realized we got to this point and we have not found any music tracks yet. So at this point, you would want to import music tracks, find some online. I have a couple that I'm going to import, but whatever you music tracks, just get them from somewhere. Generally speaking, waves are going to be higher quality, but higher file size, and they're going to loop better. MP3s, I mean, you can use them for some things, but you're going to notice some hiccups when they loop. So I'm going to grab my music tracks. Once you get those, just drag them in. Might take a second. Let's take these, we'll group all this together and organize it in a little bit. So I have 3 different tracks here and I want to test to make sure that I can play them appropriately. All right, once you're inside of here, I'm going to be using the new Unity input system for this. I'm not going to bother setting up actions and stuff just for testing, but I am going to test a key press through their new system. So you may need to import the package for that if you're not already using it, and it may need to restart depending. Just look into their new Unity input system. First, let's add, I'm say using Unity engine.input system. All right. Again, import the package if you need that. Next thing, I'm going to create a couple of variables to say which song do you want to play for testing. So we'll say song 01, do another one for song 02, and let's do one more for song 03. And then we can trigger these at different points in time. The way that you would actually use this, you might have combat track or starting music track or level background ambience or whatever it is that you want. I'll say private void update. I'm just going to test for the keyboard press. So if, let's say, keyboard.current, let's just test on Q key was press this frame. All right, so if it was press this frame, then I want to do that. Let's copy this, paste it a couple times. So then I want to test, let's replace this with W key, then E key, and then the last one we want is space. We'll do stop on space. Everything here is set up. It's independent of our tool. The nice thing about the way that we've set up our system is through the scripts, empty scene. All we need to do is call one line and it'll set itself up and it'll do our fade. We don't need to worry about it ever again. So when we press Q, musicmanager.instance.play, it's looking for a song. So let's give it the song we want to play, song 01. And a fade time. You can put anything you want here. I'll put 2 seconds. Yeah, let's do 3 just so we can hear the fade a little bit more. When we press W key, let's do the same thing. Let's play song 02 and let's give it a really quick fade. Let's do 0.5 F. When we do song 3, let's give it a long fade. So I'm going to copy this again, change it to song 3, let's say 6 seconds so that we can hear the difference. It may not sound good, but we can, hear and tell if our system is working. And the last thing we want to do, let's copy that. Instead of playing, we want to stop and then give it a fade time. I think let's do 4 seconds. And this is it. This is how you can use it. This is how you can call it. But the last thing we need to do is actually hook into our inspector. So let's hook in, these are some songs I did a while back. And the last thing that I realized that we need before we can actually hear these songs, we don't have a pair of ears inside the scene, right? We're playing something, but we need a listener. So the easiest way to do that in our testing scene is to right click, create a camera. In other levels, you will have this somewhere, this audio listener, but I'm just going to add the camera just so that we can hear things inside the scene. So I want to make sure we have that. Now let's play. And what I'm going to do is I'm going to click play and then I'm going to listen and watch. So first let's spawn our thing. Let's press Q. I'm going to pause it here. I'm going to click my Music Manager just so that we can see what's happening with the volume knob. So next I'm going to unpause. I'm going to press W, then E, then space. Right? You see that quick fade? Okay, so got it working there. And then we're going to press spacebar to stop and fade out. All right, so hopefully you can see how powerful that is, right? It's simple. It is doing the fades that it needs to do. We're doing some crossfading between tracks. And the cool part is it's all inside of scripts. There's no real setup apart from somewhere you have to call it, right? And you have to give it a clip or, some kind of music track to play. But very simple, very reusable. Now, I'm mentioning that it's reusable, so we're still not done. The last thing we need to do is package up our tool so that we can pull it into future projects or pull out the reusable parts and reorganize it a little bit. So I have this folder called _game over here. Anything that is specific to our game, I'm going to put up there, and everything that is reusable, part of our tool, I'm going to keep out here inside of MusicPlayer so we can export it. So our music tracks, we do not want to deliver that as part of our tool, right? We want a designer to supply their own music tracks. And pull these out into _game. I am also going to pull out our scene, right? We don't need to deliver our scene as part of our tool. Our tool is just these 2 scripts. So I think our scene and our script inside of our scene, I'm going to pull out of there. Now over here, we could group that however we want. Maybe we call this music test scene or something, right? And we could pull it into a subfolder. But the important part is that that is separate from our 2 scripts that we actually need to run our tool. So now that we have a folder called MusicPlayer, and then we have our 2 scripts here, you could even call this like MusicPlayer tool. That's probably a better name for it. So we have this. Now, if we right click this folder, right? Music Player with only these two things underneath. And right click, export. We're going to say include dependencies. Let's uncheck that. So it's only Music Player tool and Music Manager and Music Player. We export that. It'll ask us where we want to save it. Put this anywhere we want, desktop, whatever. Just long term, you want to move that somewhere. Call it Music Player tool. All right, so we exported a Unity package. So if I look on my desktop, it's right here, our Music Player tool package. Here's why it's important. Let's say that for whatever reason, I deleted everything. Let's say it's a different project. We have our music test scene. We have some things over here where we're using it, but our Music Player tool no longer exists. We're inside of a new scene. Now I'm going to get some errors in here, right? Because music test scene is trying to access these scripts that don't exist anymore. That's fine. You could delete this out too if you want. But what I want to show you is if you just import it, like you can go assets, import package, custom package, go to wherever you saved it, our Music Player tool. We can import it and we're just importing the scripts. So this is how easily you can get this into a new project, right? We have the package, we just import it. We say, yes, we do want these two scripts. We import it in, and now we can play our music, right? So this is how we can make it reusable. We just pull this into any future project that we want. So ideally, from this point, you could continue to modify this. You could add new features, right? We're not even dealing with mixers and things, more complex fading. Maybe you want different kinds of curves or whatever. You could continue to improve this if you want, but I really wanted to show you how you could do this all from just two scripts, fire and forget. It's not even loaded until you use it for the first time. Very little setup, and that's the advantage of this approach. So the last thing I want to add here real quick is what we've built so far is pretty easy, drag and drop, one line, call it in code. If you want more features like mixer support or sound effects, things like that, I do have a longer series on how to do that. So you don't have to for what we're doing in this tutorial, but if you want to build this out, I do recommend going through this other series if you want something more robust that you can use in a bigger project. So I'm pointing to it. It's Sound System Tool in Unity. If that's interesting to you, click that. Otherwise, I think you have what you need to fade your music.